Okay, ladies and gentlemen, let's talk a little bit about percentiles and quartiles. And we're going to think about percentiles as slicing data, just like we would slice a loaf of bread. What we do is we can take a data set and we can slice it into 99 pieces. Technically, there's 100, but we don't count the heel because 100 slices of data is all of the data. We refer to this as the nth, n representing the number of the percentile. The nth percentile is the value such that at least that n% of the data are below that value, and at most 1 minus n% are above that value. So if we were looking at the 40th percentile, that would be the value such that at least 40% of the data are below that number, and at most 60% are above that value. So how do we find these percentiles? First thing we've got to do is we've got to sort the data from smallest to largest, and then we are going to locate I. We think of I as the index or the indicator, or in some cases we can think of it as the information, just like that little I thing that we get when we look on the internet. When you click on that, it gives you more information, and we're going to do that by applying this formula for I, which is going to say whatever percentile I'm looking for times n, total number of observations, divided by 100 will give us the location of that percentile. Let me show you how it works. So remember I said that we had P for percentile and the number of observations, I, this I is the location, and we have two rules that we have to follow. If the result of this formula for I is a whole number, then we're going to take I and I plus 1 and we're going to average them. Very much like you do when you have an even number of observations in a data set and you're looking for the median. If I is not a whole number, one way you can look at it is you're simply going to round up to the next whole number, or we can do this fancy thing where we take I and we go I plus 1, and then we take simply the whole number portion of that result. It's kind of fancy. I don't know that we need it, but I'll show you how to do it. So here I have my data, and I have 12 observations, and you've been asked to locate the 17th percentile. What you've been asked to do is to locate the value below which 17% of the data falls, meaning that 83% of the observations are larger than that value for the 17th percentile. So what did I do? I went in and I sorted my data from smallest to largest, and now I'm going to apply the formula that we looked at a minute ago. P is 17 because I wanted the 17th percentile, N is 12. So if I counted these up over here, I would have 12 observations. And so I'm simply going to do the math and substitute into the formula, and I get I as 2.04. Well, remember back up here, I said if I is not a whole number, we can round up, or I can do this other fancy math, and I'm going to show you the fancy math. Here's the fancy math. Remember, we got 2.04, not a whole number, and I simply added 1 to it. And now what I'm going to use is I'm going to use the whole number portion to locate the 17th percentile, meaning we need to find the value that falls at I of 3. This is where I could have said you could have just rounded up, but mathematically rounding 2.04 up to 3 is weird. So that's why we go ahead and say just add 1 to it and then use the whole number portion of the result. So now I'm going to find the third observation. I'm going to begin from the top. I'm going to say this is value 1, 2, 3, the value that falls in the third location, right? I equal to 3 is the 17th percentile. And what that tells me is that approximately 17% of the values in this data set are below 13, and the other, remember 1 minus p, the other 83% are larger than 13. So, not too bad. Let's see how it goes from here. So just to summarize, remember we said that the 17th percentile was located at 13. That meant we had 17 of the values smaller than 13 and 87% larger. Remember, we're slicing data, so we can really think of making a slice and cutting it so that this slice represents 17% of the data and this big slice represents the other 87% of the data. It's kind of like how I prefer to cut my cheesecake. I want the 83%. So let's move on now to quartiles. Well, if we know that percentiles break things into technically 100, although we only count 99 of them, then it should make some kind of sense that quartiles break them into blocks of 25. So when you looked at the very first slide in this presentation, you noticed that I had pennies and quarters. Well, always remember 4 quarters to the dollar, 4 quartiles to a data set, 100 pennies to the dollar, 100 quartiles in the data set. I like to think of butter because I'm always have recipes that say I need a quarter of a stick of butter. And so the question becomes, how then do I know where to cut my butter so that I have it cut into even quarters, especially if it's one that I've already used and I've lost those nifty little lines at the bottom. So let's show you how to do that. So when we look at this measure of central tendency of quartiles, we just separate the data into 4 subgroups or quartiles, and we refer to those as Q1, Q2, and Q3. Yes, theoretically there's a Q4, but just like the 100th percentile, it's simply the value below which all of the data falls, so it's really kind of meaningless. So we always talk about Q1, Q2, and Q3. We'll also talk about Q1, Q2, and Q3 as lower, median, and upper quartiles. Think about this quarters, dimes, and pennies again, right? If I owe you 25 cents, I could give you 1 quarter or 25 pennies. If I owed you 75 cents, I could give you 3 quarters or 75 pennies. So the process for converting these quartiles back and forth to percentiles is very much the same. In other words, we're going to do the Lord of the Rings approach. It's going to be one formula to rule them all. So the first thing I want to do is I want to find Q1. Well, we said Q1 is the same thing as P25, So I am using that exact same formula where I end up with I equal to my percentile times the number of observations I have divided by 100 is going to give me 3. Now in this case, we came up with a whole number. Before, remember, we had one with a remainder. So what do I do with a whole number? I'm going to average the third and the fourth values. I turn my data on the side, and so what I'm going to do is I'm going to say this is 1, 2, and then here are 3 and 4. So I'm going to take 13 plus 14, I'm going to divide it by 2, and I'm going to find that Q1 is at 13.5. It's halfway between the third and the fourth values. So what if I wanted Q2? Well, Q2, not QE2, the famous ship. Q2 is the same thing as P50. So again, I'm going to take my P and I'm going to multiply it times N, divided by 100. I'm going to get 6. Well, 6 is a whole number, so I'm going to average the 6th and the 7th. So I'm lucky this time in that it's 17 is 1, 2, 2, 2, 3, 4, 5, there's 6, there's 7, so now I know Q2 is equal to 17. Let's see what it looks like for Q3. So if I wanted to find Q3, I'm going to do this one by hand. Now what would I be looking for? Yep, P75. Because what I know is that 3/4 is the same as 75 pennies. So instead of 50 here, I'm simply going to put 75. This part of the formula remains unchanged. And we're going to say that 12 divided by 100 times 75 is going to give me now the 9th, that's a terrible looking 9, and the 10th. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is going to be here. So I'm going to take 20 plus 21. I'm going to divide them in half. I'm going to find out that Q3 is 20.5. So really what I'm doing is I'm taking my butter and I'm literally finding the half and then the half of the half and then the half of the half. So if I went back and I looked at, say, this slide to figure out where was I, okay, what I know is that here is P50, okay, or Q2, which is the median, and now I know that I found Q1 here, and now I found Q3 here. So now I have Q1, Q2, which is the same basically as the median. I have Q3. And what you'll see is that I have the exact same number of data points in each quarter, or my butter, right, is evenly, not to scale, is evenly divided into 4 pieces. So using this same formula for the location of I for both percentiles and quartiles works out just fine. But you knew you weren't going to get out of here that easy. A word of caution. Different software applications calculate percentiles and quartiles differently. If you're using a TI-84 calculator, you may find that you get a different result than using Microsoft Excel. you use Microsoft Excel to find your percentiles and quartiles, you will see that there's more than one formula available. One is an inclusive and one is an exclusive. If you're using Minitab, the statistical software package, you may very well get a different value for your percentile or quartile than you do for Excel or the TI-84. If you're using StatCrunch or another software package, you may get yet another value. So, a word of caution. If you're in a class taking a course, like my students are, follow the process used by your textbook author. If you're not, then use the process that you are either comfortable with or is driven by the type of data you have. Some processes are much more precise than others. So when in doubt, always go back to the source. Go back to your data. Think about the question that you're being asked. Determine what degree of precision is appropriate for the data you're working with, and then proceed accordingly. So, not a topic that is exceptionally tough, but like all statistics, we got to put that twist in there at the end. Until next time, guys, have a great day and data on.